Hi, this is Mrs. B, and welcome to Math for All, where everyone can learn more about math. If you're serious about learning this topic, and I do hope that you are, please go to our website and get the notes for this video and go ahead and fill them out as we go along. While you're there, go ahead and gather up some fun colored markers too. Today, we're going to learn how to add fractions with different denominators. We'll start with pictures to show the issues in having different denominators. Then we'll give some examples of adding with different denominators. I'll summarize your steps in finding the best common denominator, and then of course we'll practice what we've learned. In my previous video, I told you that we have to have the same denominators when adding fractions. But why is that? Well, take a look at these two fractions, 2/4 and 3/8. If I pull out what they look like this, and think I'm going to add them, it just won't work. These cannot be combined because they have different shapes. But what can we do about this? We've already learned a tool that can be used to change the numerators and the denominators, and that's what we're going to use. Do you remember what that was called? Equivalent fractions. That is what we will use to make the denominators the same so we can add them. Let's watch this in action. We'll take the same example, 2/4 plus 3/8. I like to stack my fractions because my rainbows work better that way. I draw nice arrows to show what they will transform into. Remember, our goal is to get the same numbers on the bottom, so I need to find a number that they both go into evenly. Here are my steps to figure it out. Look at the denominators. For us, we have 4 and 8. I'll write them over here to the side because I have to do some math work. Circle the bigger number, the 8. Check and see if the other number, 4, goes into that 8 evenly. If it does, it's a winner. For us, yes. 4 times 2 equals 8, so 4 does go into it evenly. Happy face here. Now, use equivalent fractions to make both of ours have the same denominator. Write the 8 in both denominators so we don't have to remember it. The 3/8 here gets to stay the same because it already has an 8 on the bottom. We'll just bring it over. Draw your rainbows from the 2/4 so you don't forget to multiply on the top and the bottom by the same number. We'll start at the bottom. How did that 4 turn into an 8? It got multiplied by 2. So the rule is to do the same to the top and the bottom to keep an equivalent fraction. So I'll write times 2 on my 2 rainbows like this. For the numerator, I have the 2 I started with multiplied by 2 for a 4 on the top. Now we're ready to add. Add the numerators. 4 plus 3 equals 7. Keep the denominator of 8 the same for a total of 7/8. Quickly, I will show you what we did with pictures. Look at our odd shapes we were trying to add, but then we decided it wasn't just going to work out too well for us. I can cut each of these into 2 pieces, which makes them the exact size and shape as the 3/8. This will give us 7 pieces of the same shape, which are eighths of our circle. Ready for another example that will take just a few more steps? You know, that's how math is. We show you how to do things, get you comfortable, then we'll take it a little step further. This example uses math tools you've already learned, but it just puts it all together. So let's do it. Here's my problem. Remember, math people are full of problems. 7/9 plus 10 and 2/15. Always stack your fractions. It does make it prettier. Look at the denominators. 9 and 15. Too bad they're not the same, but it will be good practice for us. We'll rewrite them somewhere else so we can do our work. I will write them here. Nice color too. Remember my next step in finding the denominator we need? Circle the bigger number, 15. Okay, now we see if 9 goes in evenly to 15. Nope, not the last time I checked. Since it is not the winner, we will go up again by our bigger number, 15 times 2, or 15 plus 15, 30. 30 is our new number to check. Does 9 go into 30 evenly? Nope, not my winner either, but don't be discouraged. We just have to be determined and keep going. So now we're at 15 times 3, or we can take our 30 and add 15 like this. Either way will work because we'll still get the answer of 45. And now, does 9 go in evenly to 45? Yes, because 9 times 5 equals 45. We have a winner, friends. It makes me want to put a gold star by it. But don't let me get too distracted because we still have a math problem to do. So back to our original problem. Draw the transforming arrows. Bring over the whole numbers of 7 and 10 like this. Draw a fraction line and put our denominator we just spent all that time figuring out on the bottom of each. So 45 goes here and here. Draw rainbows to make equivalent fractions. Get a new color if you'd like to make it as pretty as possible. This step is very important. Of course they all are, but I see a lot of students making a mistake here and I don't want you to. You need to take each fraction separately and figure out how their denominator turned into 45. I'll start with the top fraction. How did that 9 turn into 45? 9 times what equals 45? 5. So that's what goes on my rainbows, and I will multiply the top by 5, resulting in 25 up here. Nice. Next up, the bottom fraction. 2/15. We need more rainbows. It can get a little crowded, but it's because we're doing some great math work here. 15 times what equals 45? It's 15 times 3, so multiply the top also by 3. I will write it across both rainbows so I don't forget what I'm doing. And 2 times 3 equals 6. Phew! After all that, we can now add the way we know how. First, we'll add the whole numbers. 7 plus 10 equals 17. Put that here. Add our numerators, remembering those are the number of pieces. 25 plus 6 equals 31. That goes on the top of our little fraction. Bring down the denominator of 45 that we worked so hard to get for a total of 17 and 31/45. Finally, I check to see if it's in proper form. Remember, not improper, and make sure that it's fully reduced. Thankfully, yes, this one is done. Celebrate with a happy face. You've seen the process and are doing great with it, so let me summarize my steps in finding the common denominator. It is also called the least common denominator, or LCD. It means the smallest number that the denominators can both go into. We want the smallest number so we hopefully won't have to reduce later. See, we're trying to do the least amount of work possible, even if sometimes it doesn't feel like it. Back to our steps. Circle the bigger denominator. We do this because it makes it quicker to find the common denominator. See if the other denominator or denominators go into it. If we're adding 3 numbers, all denominators have to go into it. We'll practice one like that, so don't worry. If the other denominators go into it, you found your winner and gold star for it. If not, then go up again by your circled number. Either multiply it by 2 or add it to itself to do that. Check again if the other numbers go into it. If yes, it's a winner. If not, keep going up by your bigger number until it works. Let's try this one, where we'll just find the common denominator. We won't add them up, we'll just practice the new stuff. Look up here at my numbers. 4 and 5/6, 2 and 2/9, and 3/4. We'll follow my process to find their LCD in case I had to add them. I will write the denominators to the side here. 6, 9, 4. Circle the biggest number. I can handle this step, right? Circle the 9 right here. Next step, do the other numbers. 6 and 4 go in evenly to 9. Nope, we've got to keep going. We'll take my nice circled 9 and add 9 to it or multiply it by 2. Both of those would equal 18. Do 6 and 4 go into 18? Well, 6 does, but since 4 doesn't, I'm not done yet. Take that 18 and add another 9 to it or multiply your 9 by 3. They both equal 27. Do 6 and 4 go into 27? Nope, neither do. It seems like we're not getting close to the answer, but sometimes it works out this way. Start with the 27 this time and go up by 9, or do 9 times 4 equals 36. Do 6 and 4 go into 36? Hip, hip, hooray, they do. 6 times 6 equals 36, and 4 times 9 equals 36. We have our winner. Our LCD of 4, 6, and 9 is 36. It's time to practice what you've learned on finding common denominators and adding fractions. Here we have this innocent-looking addition problem. 5 2/3 plus 1 5/8. We will not back down. We've got this. Our denominators are not the same. Remember, they are different sized pieces. We must find the LCD. Write the denominators over in another spot. Here is good. 3 and 8. Easy step, circle the bigger number. 8. Does 3 go into 8? Nope, we've got to go up by 8. 8 plus 8 equals 16. Does 3 go into 16? No again. Go up by 8. 16 plus 8 equals 24. Does 3 go into 24? Yes, I declare our winner 24. Going back to our original problem up here, draw some nice arrows over, copy the whole numbers over, 5 and 1 here. Draw your fraction line and put our common denominator of 24 under both. I'm going to get another color for the next step. It's rainbow time. We'll figure out how each bottom number turns into 24, and we'll be sure to multiply the top by that. Starting with the 2/3, 3 times what equals 24? 8. So we put the times 8 on our rainbows and multiply the top. 2 times 8 equals 16, which goes right on top. For the bottom fraction, 8 times what equals 24? 3. So we mark times 3 on our rainbows and figure that 5 times 3 equals 15. I'm ready to add. 5 plus 1 equals 6, our whole number. 16 plus 15 equals 31, our numerator. The 24 just drops on down for a total of 6 and 31 24ths. Yay, we did it! Is it time to circle our answer and be done? Nope, not yet. Why not, we all ask? What's wrong with the form that it's in? Right, we have an improper fraction. Bummer. Let's take care of it like we know how to do. Divide out 31 24ths. 31 divided by 24 equals 1 with the remainder of 7, which turns into 1 7 24ths. Add that whole 1 to our other whole number 6, giving us 7 wholes. Drop down the 7 24ths for a total of 7 7 24ths. Now we can circle and celebrate. Wow, you have learned the many steps in adding fractions with different denominators. Congratulations! Time to practice on your own. Go get a worksheet on this lesson from our website and go for it.